The development of nuclear weapons marks a dark chapter in human history. In addition to strategic nuclear weapons for national deterrence, tactical nuclear weapons also exist. How do the two types differ in terms of explosive power, range, and deployment scenarios? What damage do they cause? What are the mortality rates? And what risks do they pose to our future? You'll find out by the end of the video. Stay tuned. Welcome to Erklärwürdig, worth explaining. Before we go into detail, what are nuclear weapons? Nuclear weapons, or atomic weapons, such as atomic bombs or hydrogen bombs, are weapons of mass destruction with long-term consequences based on nuclear fission or nuclear fusion. A nuclear weapon releases heat, pressure, and ionizing radiation, and has by far the greatest destructive potential of all current weapons. There are currently over 12,000 nuclear warheads worldwide. The United States and Russia possess approximately 90% of them. Official nuclear weapon states, in addition to Russia and the United States, include France, Great Britain, and China. In addition, there are 4 de facto nuclear weapon states: Israel, Pakistan, India, and North Korea. Of all the warheads currently in use, approximately 3,800 are operational. By comparison, during the Cold War and the arms race between the US and Russia, they possessed a combined total of around 70,000 warheads. Even though there are significantly fewer nuclear warheads available today, they are still easily sufficient for so-called overkill. This means that the world could be destroyed many times over with the current arsenal. If we take the approximately 12,000 existing nuclear warheads as a basis and assume an average of 200 kilotons per bomb, we would arrive at a total explosive force of 2.4 million kilotons, that is 2,400 megatons. In the end, it doesn't matter which values we use, whether slightly higher or lower. Let's use the calculation we just performed with 2,400 megatons for comparison. The destructive power of the entire Second World War was calculated at around 3 megatons. This means that the total explosive power of the nuclear weapons in existence today is equivalent to 800 Second World Wars. States, militaries, and strategists distinguish between tactical and strategic nuclear weapons. The difference lies not in the actual technology of the bomb, but rather in the context of use and purpose. Strategic nuclear weapons are part of a deterrence strategy and were originally designed to hit distant targets of 5,500 kilometers or more while simultaneously causing widespread destruction. Their explosive yield could theoretically exceed 100 megatons. Current strategic nuclear warheads are more likely to be in the range of up to 1.2 megatons or 1,200 kilotons, such as the US B-83 hydrogen bomb. By comparison, the atomic bomb dropped on Hiroshima in 1945, which caused more than 140,000 deaths, had an explosive yield of around 15 kilotons. Strategic targets would typically be enemy cities, industrial complexes, or nuclear weapons arsenals. During the Cold War, the United States and the then Soviet Union massively expanded their nuclear arsenals to ensure they could launch a lethal counterattack in the event of a first strike. This nuclear deterrent principle, whoever shoots first, dies second, still holds today and poses a permanent threat to all of humanity. To uphold this principle, or, to put it more drastically, to ensure mutual destruction, the nuclear-armed powers, the United States, Russia, and China, operate the so-called nuclear triad. This is intended to ensure a state's ability to carry out a nuclear retaliatory strike using 3 different systems. Other countries have 1 or 2 such systems. On the one hand, there are land-based intercontinental ballistic missiles, which are usually stationed in silos deep underground and have ranges of over 10,000 kilometers. Nuclear warheads can also be fired from mobile rocket launchers. The gold standard is probably sea-based missiles launched from submarines. Even with today's technology, submarines are very difficult to locate, highly mobile, and have ranges of approximately 2,500 to 11,000 kilometers. This makes them globally deployable. Imagine that right now, nuclear-armed submarines are constantly operating in all oceans. In the event of a first strike, this system would have the greatest chance of survival, and thus probably the best opportunity for a counterattack. The third system would be air-launched nuclear weapons, which can be dropped by aircraft or delivered to their targets by rockets and cruise missiles. If one system fails, 2 others remain functional. Each component has different response times. The triad is intended to create a credible deterrent through redundancy and flexibility. In contrast to strategic nuclear weapons, so-called tactical nuclear weapons have also been produced over the years. Their intended use is on the battlefield during a conventional war, for example, to halt large troop movements or destroy other military targets at close range. The ranges, usually less than 500 kilometers, are the key difference from strategic nuclear weapons. Likewise, the explosive yields are said to be in the range of 0.3 to 50 kilotons, and some can also be fired from conventional artillery pieces. The distinction itself is very misleading, since some nuclear weapons with adjustable yields between 0.3 and 170 kilotons are also considered tactical. If we return to Hiroshima, the bomb dropped at that time, with a yield of around 15 kilotons, was considered a strategic nuclear weapon. Even in terms of distances, a clear distinction cannot be made between strategic and tactical. India and Pakistan, for example, are neighboring countries, and despite shorter ranges, one would probably speak of a strategic nuclear deterrent. What would be the consequences of the use of nuclear weapons? We'll first look at Hiroshima again and then examine the effects of a 1.2 megaton atomic bomb. After the bomb was dropped on Hiroshima, a fireball developed with a surface temperature of more than 6,000 degrees Celsius, similar to that of the sun. A pressure and heat wave spread at supersonic speed. Around 80,000 people died instantly. Within seconds, 80% of the city center was completely destroyed. Even 2 kilometers away, people suffered third-degree burns. Rapid relief efforts were nowhere in sight, as hospitals were also destroyed and doctors and medical personnel were among the victims. Due to a lack of assistance, hundreds of people died within hours from their injuries. Others died a gruesome death from radiation sickness days and weeks after the detonation. By the end of the year, the death toll had risen to more than 140,000. Even years and decades after the atomic bombing, survivors continued to suffer from various types of cancer. Today's strategic nuclear weapons have a significantly higher explosive power than the Hiroshima bomb. The death toll would be unimaginably higher. For example, consider the detonation of a 1.2 megaton hydrogen bomb in a modern city with approximately 1.5 million inhabitants. Nucamap, for example, can be used as simulation software. You can find the link in the video description. These figures are very rough estimates, but they are sufficient to illustrate the insanity and cruelty of a nuclear war. The simulated detonation occurs at an altitude of 900 meters. The fireball has a radius of over 1 kilometer. The pressure and heat wave destroys even heavy concrete buildings within a radius of 2.5 kilometers. The number of immediate fatalities is almost 100%. Within a radius of about 6 kilometers from the center of the explosion, most residential buildings collapsed. A large portion of the population dies instantly. Within an incredible 13.5 kilometers, the third-degree burn rate is still at 100%. The pressure wave will break windows within a 15-kilometer radius, also resulting in injuries and deaths. The simulation estimates approximately 600,000 deaths and over 400,000 injuries. Fallout effects are not even included. According to a study commissioned by Greenpeace, it is roughly assumed that 50% of people outdoors, 125 kilometers away from a 1 megaton explosion, would receive a lethal dose of radiation. However, the fallout cloud would take several hours to reach the area, giving people time to seek shelter or leave the danger zone. A 2022 study in the journal Nature Food estimated that a nuclear war between the US and Russia would result in 360 million deaths from the nuclear weapons themselves. More than 5 billion people would starve or be at risk of death within 2 years, because the food supply would no longer be secure due to the initial enormous amounts of soot in the atmosphere. Conflicts between supposedly smaller nuclear powers such as India and Pakistan also have equally serious consequences. Regardless of whether tactical or strategic nuclear weapons are involved, escalation after use is difficult to prevent. It remains to be hoped that all actors are aware of their responsibility. Nuclear weapons are a terrible invention. If you enjoyed the video despite the sensitive topic, I would appreciate a like and a comment. Don't forget to subscribe to my channel. I look forward to next time.